All right, so we are continuing our lesson on functions, and we are going to look at graphs today. As you can see, it says graphs are one of the most powerful ways of visualizing a function's rule because we can quickly read the outcomes given the inputs. You can also easily see features such as maximum and minimum. So over here we have a graph, right? We have no idea what the equation is, but we do have this lovely graph. So let's review for a second here. Remember, f of x really is fancy talk for the y. We'll get into this a little later about why we changed to f of x and y, but for right now, let's just realize that they mean the same thing. We want to understand what f of -1 means. It means put -1 into the function, right? That is an input. We are putting -1 into this function. And it's really easy to see what the answer is. I'm going to get a line. And what happens is I go to where -1 is on the x-axis, and I draw a line. Voila! Where does this red line look like it crosses my graph? And if I look closely, it looks like the answer is right here. So when I put -1 into this equation, my answer is 1, 2, 3, 4, 5, 6. See, if some of you noticed, this is really just fancy talk for a point. See, this is the point, -1, comma 6. When I put -1 into the equation, I get 6 as an answer. Okay, let's keep going. This time it says put 4 in. So I'm just going to go over to where my x values are 4, right there. And what's the point? Where they cross. Right there. This is the point 1, 2, 3, 4, as we just noticed, over 4, up 1. So we found out that if we put 4 into the equation, my answer is, sorry, if we put 4 into the function, my answer is 1. X value, Y value. Now careful right here, this is a little different. This is not asking me to put -2 into the equation. This one is asking me what X value or what input results in -2 as the answer. So that means I'm going to have to take my line here, and I'm not looking at the X values anymore. I'm looking at the outputs. So this is my output of -2 right here. And I've got 2 answers. Right here and right there. So what X value results in -2 as an answer? Well, it looks like if I put in 1, I will get back -2 as an answer. Or if I put in 3, I will get back -2 as an answer. Now, if we look at this graph, is there a maximum to this graph? No, because our graph goes on forever and ever. I know there should be arrows written there to signify that it goes on forever and ever. Sorry, I'll put those arrows in right now. But there is a minimum. There is a minimum. the lowest point, and it looks like the lowest point on this graph is 2, 1, 2, 3. There is a minimum of when I put in a 2, I get a negative 3. So there's a minimum point. We would write it in function notation. When I put a 2 into the function, the result is a negative 3. All right, so now we are actually going to be given a rule, or fancy word for equation. Let me change this pen color. I don't like red on orange. That's yucky. All right, there we go. We're given an equation or a rule, and this function is called g. So over here, I'm going to add the name to that. And what does function g do? Function g doubles everything that's inputted and then adds 3 to it. So as we see here, functions can be displayed as a table also. So this is our table. And all this is saying is, okay, here are the values I'm going to put into this machine or this function, and this is what it does. This one tells me that I'm going to double my x value and add 3. Double negative 3 is negative 6, and I get negative 3 as an answer. Now notice how they want me to write it over here. They want me to write it in point notation. So this is saying when I put in negative 3, I get negative 3 out. Okay, this tells me to double and add 3. Negative 4 plus 3 is negative 1. Okay, this tells me to double and add 3. So when I put a negative 1 in, my answer is 1. All right, this one tells me to double. All right, so you see the pattern, double and add 3. So when I put a 0 in, my answer is 3. This tells me to double and add 3. So when I put a 1 in, my answer is 5. This tells me to double and add 3. So when I put a 2 in, my answer is 7. And this one tells me to double and add 3. So 6 plus 3 is 9. So when I put a 3 in, my answer is 9. All right, now we can also take this function and represent it as a graph. So it simply means I'm just going to plot all my points here. Hopefully you recognize it as a line. So we shouldn't be surprised with the shape this makes. So when I put in a negative 3, negative 3, so this is the first point I'm graphing. Done. Negative 2, 1. Negative 2, sorry, negative 1. Negative 1, 1. 0, 3. 1, 5. 2, 7. And 3, 9. I'm going to come over here. I'm going to get myself a nice line. And there is my function. Now, if you remember all the definition, all the things that we know about a function, x values, can't repeat. We definitely see this here. Remember, these lines that go vertically are your x values, and never once do these x values cross that green line more than once. All right, here's another function. And this time the rule, or the equation, is asking me to square everything I put in. Okay, so this is the rule that we're going to call h. So this is simply asking me to square everybody that I put into it. All right, so when I put a -3 in, my answer is 9. When I put a -2 in, my answer is 4. When I put a -1 in, my answer is 1. When I put a 0 in, my answer is 0. When I put a 1 in, my answer is 1. When I put a 2 in, my answer is 4. And when I put a 3 in, my answer is 9. So same thing. Can we represent this on a graph? We know what it's represented as an equation. We've seen its table. Now let's get a picture of it. We're humans. We like pictures. -3. 1, 2, 3, 4, 5, 6, 7, 8, 9. I'm going to put a -2 in. I'm at 4. I'm going to put a -1 in. I'm at 1. 0, 0. I'm going to put a 1 in. I'm at 1. When I put a 2 in, I'm at 4. When I put a 3 in, I'm at 9. And this makes, hopefully you know what the name of this shape is, it's a parabola. It is a function, as the problem told us, because nowhere do the x values ever repeat. So if I were to draw a nice little line right here, and I were to do my rule, only crosses once, once, yep. Nowhere where I put this red line does the red line cross the parabola more than once. All right, here's example 3. Look at this mess right here. Whoops, sorry. Look at this mess right here. What is that? This is very important. This is called a piecewise function. Because I'm giving you two pieces. Here's the first equation, and here's the second equation. All right, so what does a piecewise function mean? We look at it in pieces. We have this first piece. And this piece we will use if our inputs, our x's, are less than 0. Here's our second piece. We use this piece if our x values are greater than or equal to 0. So we're going to come over here and we're going to create a table. And we're going to start with the numbers. Let's start with -4. And let's go all the way, but wait a second. If we're inputting an x value that's greater than or equal to 0, we have to use the other piece. So I'm going to change my pen to green because 0 is greater than or equal to 0, and the colors here signify that these x values are associated with which piece of the function. All right, so if I put a -4 in, that's indeed less than 0. So they want me to double -4 and add 6. Gets me -8. I'm going to double -3 and add 6. Gets me 0. I'm going to double -2 and add 6. Gets me 2. I'm going to double -1 and add 6. That gets me 4. But now notice I'm going to look at the other piece of the function. Because they said when my x values are greater than or equal to 0, I got to use the other one. So 6 minus 0, 6. 6 minus 1 is 5. 6 minus 2 is 4. 6 minus 3 is 3. And 6 minus 4 is 2. All right, so let's graph these. And again, I'm going to use two different color pens. So this is the point when the x value is negative 4, my y value is negative 2. When my x value is negative 3, my y value is 0. When my x value is negative 2, my y value is 2. And when my x value is negative 1, my y value is 4. Now, this is a line. So I'm going to come over here, I'm going to get my line tool. And my line was going all the way off in this direction. Put an arrowhead on here because I can keep going on and on. But actually right here, I keep going because all these numbers are less than 0 also. And I actually go up to where x is 0, but I put an open circle there because I can't pick the number 0. That has to go to the green piece of the function. So that open 0 enclosed circle are coming into play again. So let's graph the green line. So when I'm at 0, my y value is 6. 1, 2, 3, 4, 5, 6. When I'm at 1, my y value is 5. When I'm at 2, my y value is 4. When I'm at 3, my y value is 3. And when I'm at 4, my y value is 2. And this function looks like it's going from here this way. And again, we're going to put a line on it with an arrowhead because it goes off in that direction. So we can get some weird shape here. Now notice that right here, this closed circle happens to cross over to the open circle. That's not always going to happen, just in this special case. Okay, we're going to do a lot with piecewise functions in the next few days, so you're going to see a lot more of them.